Hi, my name is Nadine, and today I'd like to talk to you about the results of a research project that was conducted at Central Queensland University. It looked at the acute effects of vibration training on plyometric push-up performance. Just a little bit of background details. Vibration was first introduced by two Russian scientists in 1985 who were looking at vibration and the effects that it would have on flexibility and strength in their athletes, and they found that after vibration training that they actually improved. Today it's widely used in fitness clubs, rehabilitation centres and by professional sports teams and athletes. It can be used as an alternative to conventional resistance training or as a supplementary training to enhance performance or even in rehabilitation. It involves standing or exercising on a vibrating platform. Plyometrics exercises involves the use of fast eccentric loading to produce increased concentric force, also known as a stretch shortening cycle. There have been conflicting results from previous studies. This is because it's been difficult to compare studies because each study's used various protocols, different methods of applications, has different vibration parameters, training duration, and the types of exercises performed. Different vibration platforms have been used, such as an oscillating versus a vertical platform. Some studies have shown that whole body vibration training has increased muscle strength and power, has improved endurance and changed muscle morphology. Other studies contradict this and say that it didn't increase maximal muscle strength or power. Just recently, a scoping review found that there was little inconsistent evidence that acute and chronic whole body vibration would improve athletic performance in competitive and or elite athletes. Out of 27 comparison studies, only 9 were found to be statistically significant. Most vibration studies have also focused on either the whole body or either the lower limb. In fact, there's few studies on upper body power, and there's even less on plyometrics that have focused on the upper body. Some studies have reported improvements in force and power output after just a single session, and others have shown as training stimulus has occurred over weeks or months. Or other studies have shown that they've had better results with untrained individuals over trained athletes. Vibrations training has been shown to be safe when it's used for a relatively short time. However, when vibration transmission frequency is too high, some people can experience motion sickness-like symptoms. Basically, we don't have a specific effects of vibration training on muscle morphology, strength, and endurance are not well understood. What are the mechanisms behind vibration training? Currently, the neural mechanisms that are responsible for enhancing muscular performance are still unclear. A common explanation for increased power output and EMG activity after whole body vibration is like this. Mechanical vibration applied to the muscle and tendons triggers the tonic vibration reflex, which activates the muscle spindles and evokes a stretch reflex loop. So we have an increased activation over the intrafusal muscle spindles, which causes an increased excitation of the alpha motor neurons, which then leads to activation of the working muscles and therefore an increase in power and force output. However, Cochrane and Hortabay debunked this, saying neural mechanisms to explain the whole body vibration effect on motor performance. They said there's virtually no evidence for such mechanisms to operate. What is the importance of findings of vibration tracing? Since most sports require movements performed with both force and velocity, which is their power, it's of considerable interest to strength and conditioning coaches and may be applicable to strength athletes for whom high power output is important in their performance, such as football players. The aim of this study was to investigate the effects of mechanical vibration on power output in a plyometric push-up. Our hypothesis was that the upper body muscular strength and power would not increase following a single vibration intervention when applied to the upper extremity muscles. We had 10 healthy exercise and sports science students from Central Queensland University who met the following criteria. They didn't have any resistance. They had previous resistance training experience, no history of cardiovascular or musculoskeletal injuries. The females weren't pregnant. There were no bone fractures. They hadn't consumed an ergogenic aid in the last 4 months, and they hadn't previously trained on a vibration platform. Here's a demographic of our participants. We had 5 males and 5 females. When it comes to the procedures, the ethics of this study were considered very carefully and were approved by the ethics committee. We collected the following data from our participants: their body mass, height, age and sex. They all did the same warm-up of 5 minutes on the treadmill, and then followed by bench presses and throws. Data collected from the force plate was data collected from the force plate using the LabVIEW software. We collected the load, the air time, the concentric and eccentric rate of force development, peak power and displacement. Procedure for the push-up protocol. We had 3 trials of plyometric push-ups with both hands placed on the force plate with minutes rest between the trials. The participants made sure that their hands were under their shoulder and held a concentric hold for 2 seconds following the push. 5 repetitions of 30-second duration on the vibration platform with a 30-second rest in between, ensuring that both hands are on the platform in a push-up position with the elbows bent, hands under the shoulders and in a static positions. The participants then performed another 3 trials of plyometric push-ups on the force plate as soon as possible after the vibration, ensuring they had 1 minute's rest between the trials. A dependent paired 2-tail students t-test was applied to test for differences between the 2 test conditions with and without vibration in peak power, air time, concentric and eccentric rate of force development and projected displacement. The data was presented as means plus and minus the standard deviation and was averaged across the 3 trials. We set a statistical significance level of 0.05, and the data was analysed using Microsoft Excel and real statistics data analysis. The following equipment was used to collect the data, and these are the collection rates that we used. Here is the results of our study. Basically, there was only a slight increase in air time, a decrease in concentric rate of force development, and an increase in peak power and eccentric rate of force development. If you look at the breakdown of the individual participants' results, some people decreased in their peak power, but others also had a large increase. The largest was plus 35, and we also had a negative 21, so it was very dependent on the individual. Basically, we found no significant differences in either peak power, air time, concentric and eccentric rate of force development and projected displacement after the vibration protocol. So we accept the null hypothesis that vibration training now had effect on power output in the plyometric push-up. So what our results show that they're inconsistent with the previous experimental studies, that efficient training method to improve muscle strength quickly and without much effort, or that average power was higher for vibration training. Our results are supported by the following studies: that whole body vibration training did not increase muscle maximal strength or power output. Horta-Bagel revealed virtually no acute effects of whole body vibration on force, leg power, or athletic performance. He showed that 70% of his comparisons were statistically not significant. Unlikely that athletes would benefit physiologically or through a motor control mechanism from whole body vibration. What are some of the reasons why it did not work? The reaction to whole body vibration is training and individual dependent. The positive effect introduced by whole body vibration on the upper limb performance is only achieved when the stimulus is applied during the exercise and not before. Many studies have failed to show any positive effect of vibration because the applied vibrations did not stimulate the target muscles at their resonant frequencies. To activate the muscle most effectively, vibration frequency should be in the range of 30 to 50 Hz, and it's not clear what the optimal amplitude should be. Small amplitudes may be insufficient to elicit an enhancement. The method of vibration application. Vibration applied directly or indirectly to a targeted muscle may have an influence on the magnitude of the amplitude and frequency that it's delivered to the muscle, and therefore may have an influence on vibration training effect. There were several limitations to the study which should be considered. The small sample size. The study lacked a non-exercise control group that did not perform bodyweight training. Nearly all participants experienced discomfort in their hands when the exercises were performed. Participants should have had similar weight training experienced. It could have been a placebo effect and the tendency for one vibration frequency to be used. What are the practical implications of this study? Vibration frequency should be individualized to fully maximize the benefits of vibration training. Similar to when you go to a fitness center, they individualize the program to the client. It's impossible to receive whole body vibration sessions during competition, and in some sports, Lovell said it was difficult in soccer, and it's unlikely that whole body vibration could accurately increase highly trained athletes' competition performance. It may be of benefit to the elderly or anyone in a rehabilitation program, as little effort is required and there's no complicated techniques to master. Future studies should focus on evaluating the long-term effects of vibration training, identifying the optimum frequency, amplitude, duration and direction of exposure to improve strength and muscular performance. We should also look at the neurophysiological mechanisms involved in muscle activation when vibration in order to be able to describe safe and effective programs. In concluding, little inconsistent evidence that acute whole body vibration improves athletic performance in competitive or elite athletes. Other types of traditional exercise programs such as resistance training are recommended and are just as effective and more cost effective. The reaction to vibration training is training and individually dependent. Prolonged exposure to whole body vibration training can have major negative effects on health. Proper care should be taken when exercise programs are prescribed so as to guarantee safety. It could be a useful novel stimulus to push an athlete through the plateau. Here are a couple of my references. I'd just like to thank Crystal and all the other students who helped me in this project. Thank you.